In this lesson, I'm going to talk to you really briefly about the greatest common factor. These are those yellow pieces in your notes, which I have made available on Canvas. If you don't have these, you could go onto Canvas and print them out and write along with me. Or you can also edit them in Microsoft Word if you don't have a printer. But let's just kind of fill out some of these notes, get a general idea of what a greatest common factor is, and run through some examples on how to find them. Okay, so the greatest common factor, I had you guys up here kind of explain in your own words what you think it might be, using the words greatest common factor, kind of trying to dissect it on your own. But I'll let you know that the greatest common factor is the greatest. That might be kind of obvious, right? The greatest or biggest. So what we mean when we say greatest. So the biggest number that is a factor of two or more numbers, okay? i.e. it's the biggest number that goes into all of the other numbers evenly when we're looking at a series of numbers. So our first step here in finding a greatest common factor is to list out all of the factors of each number. And you may not know quite what a factor is, so that's why I have here that factors are just numbers that you multiply together to get the final number. And we only care about whole number factors like 1, 2, 3, 4, and so on and so forth. We don't care about decimals or fractions. Okay, the next piece is to find the factors that are common between each number. So we'll see which numbers can we multiply together to get every single one of the numbers we're looking at. And then finally, we need to choose the common factor that is greatest or largest. So that's where we get the green there, we get the greatest, blue common, orange factor. So it's almost kind of like we work backwards and we first find the factors, then we go and find what's common, and then finally we find what's greatest in order to get the greatest common factor. So I'm going to take a look at some examples here and do just that. So our number one here is find the GCF, so find the greatest common factor between 18 and 6. So I'm going to run through step one there, which is list all of the factors of each number. So I'm going to just, actually let's get a different color here. I'm going to write 18 right there and 6 right there, leaving space in between the two. And the first thing I want to start with, I like to just get some order with this. So I'll start with 1. And I say 1 times what gets me 18? Well, 1 times 18, that one's pretty obvious. Next biggest number after 1 is 2. And I say, can I do 2 times a whole number to get 18? If you're not quite sure and you don't know your math facts in your head, that's okay. You take out your calculator and you say 18 divided by 2, right? You start at the top, 18 divided by 2. Oops. And then you see if you get a nice number in your calculator when you do 18 divided by 2. I promise you that you indeed will get a nice number when you do 18 divided by 2. And that number is actually going to be 9. Then you ask yourself, okay, what's the next biggest number after 2? Well, of course, that's 3. You say, can I do 3 times something? Again, if you're not sure, you take out your calculator, you do 18 divided by 3, and sure enough, we get a nice number, and that number is 6. Then what about 4? Can I do 18 divided by 4 and get a nice number? If you take out your calculator and do 18 divided by 4, I promise you that you're not going to get a nice number. So nope. No two whole numbers with one of them being 4 that we can multiply. What about 5? That's the next biggest number. Same thing, I promise if you pull your calculator out, 5 isn't going to work. The next biggest number after 5 is 6. And here's where you know you don't need to do anything further. Because I've got, as you can see, the same number in the left column there as I do in the right. Which means that I found all of my factors. Because if I were to say 6 times what gets me 18, it would be 6 times 3. Right, we've already listed 3 times 6, so we don't need to list 6 times 3, because in multiplying order doesn't matter. So I'm going to do the same thing over here for the number 6. Again, first factor, 1 times 6 gets me 6. The next biggest thing is 2, and I know that 2 times 3 gets me 6. If I wasn't sure, I'd take out my calculator and do 6 divided by 2. Next biggest number after 2 is 3, but hey, same number in both columns, and if I were to write it, it would be 3 times 2, which I already have. So same number in both columns means I found all the factors. So I did that first step of list all of the factors. Now we're going to take a look at this one in blue here and find factors that are common between each number. So let me scroll back down here. I'm just going to go ahead in blue and circle the ones that are common between each of these sections here. Okay, so I see a 1 in both sections, I see 2's common between them. I see 3's common. I also see that 6 is common, actually. So all of the factors that are listed in 6 were also listed in 18, which is kind of cool. Doesn't always happen that way. Final step I have in green there is to figure out which one is greatest. So you're asking yourself, between the numbers 1, 2, 3, and 6, which one's the greatest or the largest? Well, that's obviously 6. So your final answer is that the GCF equals 6. So you can write that as GCF colon 6, or GCF equals 6. There are multiple ways to write that. The technical full and proper way is to say the GCF of my set of numbers 18 comma 6 colon is 6. But we're not going to write it out that way every time. Just say that it's 6. Okay, let's take a look at 12 and 36. I'm going to run through that same process again, where I'm going to list my numbers right here, making sure there's plenty of room for me to write all my factors out. And let's list the factors. 1 times 12, 2 times 6, 3 times 4. Next biggest number after 3 is 4, but hey, look, I already have 4 times 3, so that's it. Those are all my factors of 12. With 36, 1 times 36, 2 times 18, 3 times 12, 4 times, oh, maybe I don't remember 4 times what. So I take out my calculator and I do 36 divided by 4. What's super nice is I get the number 9, so that's a factor. What about 5? Nope, I do 36 divided by 5 and I don't get a nice number. Next thing is 6, and I know 6 times 6 is 36. I already say number on both sides, right? If I were to then write 6 again, I know, oh, it's going to be 6 times 6. No sense in repeating those factors, so we found all the factors of 36. Take out my blue color here, let's find what's common. I see a 1 in both columns. I see a 2 in both columns. I see a 3 in both. I see a 4 in both. 6 in both. And I see a 12 in both. So once again, it happened where our smaller number had all of the same, or had factors that our larger number also has. But out of all those numbers I've circled in blue, the greatest one I'm going to write in green, which is, in fact, 12. So the greatest common factor of 12 and 36 is 12. Both times, one of the numbers was actually our greatest common factor. And that's actually going to happen a third time here. So again, 3, I'm going to write the number 3, write the number 90, start by listing my factors. Well, this one's easy. 1 times 3, nothing else multiplies to get 3, that's why it's prime. This one, there's going to be a long list of factors, and I could go on and on forever and ever and list them all. Or notice that once I get to 3 times 30, there aren't any bigger numbers than 3 that are going to go into my other guy over there, which is 3. So I can kind of stop. I don't need to list all the factors of 90. Because when I go to circle for what's common, look, I've already circled everything, 1 and 3. What's largest between 1 and 3? Well, that of course is the number 3. I just want to talk briefly about variables and cover one example regarding variables, because that's when it gets a little more complicated. So I make a note here at the bottom of the first page that sometimes you have numbers and variables. In that case, you need to find the largest number of variables that can go into both. I said both expressions or both pieces. Or if you're looking at 3 different expressions that can go into all 3 pieces. So I'm actually going to skip ahead to number 5 here, where we do have some variables going on. So again, I like to just rewrite everything to kind of spread it out. So 3x squared, 6x, and 9x squared. And we're going to find the factors of each. So with 3, we already know it's 1 times 3. I'm just looking at the numbers right now. With 6, 1 times 6, and 2 times 3. And with 9, 1 times 9, and 3 times 3. And that's it, thankfully not too much. Now I'm going to take a look at the variables and list out the variables. Remember, x to the power of 2 means x multiplied by itself twice. Oh, it's going off the screen there. Which means x times x. Right here, a single x to the power of 1 is just x. And over here again, x squared, x times x. Okay, let's find what's common. I'll circle the blue. I'm just going to look at the numbers for right now. So I know I've got a 1 in each column. And I've got a 3 in each column. See, in this case, I have to look in all 3 columns, right, before I circle it. It has to appear in each spot. Now let's take a look at our x's here. And what I'm going to do is I'll just start on the far left here. And if I can circle it in each piece, I'll include it. So I'll in black here. Oh, I can circle a single x in each one. So that's good. So I know I can smush at least an x into each piece. I'm going to come back on the left again. I can circle another x there, but look, there aren't any more x's to circle there. So while I could put 2 x's into my piece on the far left, I can only put a maximum of a single x into this piece right here, right? Because there's just an x to the power of 1. So that's the most I can put into it. So I've already found the greatest number of x's, the greatest number of variables that I can, so the large number of variables that can go into all of the pieces there. So it's just going to be an x. So now I need to say of my numbers I circled, what's greatest? Well, between 1 and 3, the number that's larger is 3. And as far as the variables are concerned, I could at most put a single x into each one. You ask yourself, how many x's did I circle in a single column here? It's not how many did you circle in general, right? Because you might say, oh, well, we circled 1, 2, 3 of them, so x to the power of 3. But can you put 3 x's into 2, or even 3 x's into just 1 x? No, you can't, right? So your final answer is just x to the power of 1. As far as the variables. And then don't forget that 3 to say 3x. It can get a little more complicated once we get several different variables, but that's kind of the basic understanding of how finding the greatest common factor works when we have an expression with variables.